Hello, folks. Welcome to Rational Science. I hope my image is okay. I hope my voice is okay. Would appreciate anyone letting me know how I'm coming out, okay, into the screen. Okay, so let me know as soon as you can. And if throughout the lecture something goes wrong, it's because I'm using a different computer. I'm not familiar with it very well. And so we'll find out what happens. I hope the class goes well today. What happened was that I gave my son Hans my computer, and he took off. He went to the States, and secret mission, undercover work. And so I won't see that until October at least. And so let me know if you can hear me okay and see me okay, okay? Anyways, a couple things. First of all, I'll be on the road next week, so I'll probably postpone the next class. Okay, so be aware of that. Probably will not happen on Sunday. Okay, that's one issue. And so, well, I don't know when I'll see you again. Maybe sometime next week. Okay. Okay, so let's move on here. First subject I want to touch upon is, again, let me know if you can hear me all right, okay? If you can see me all right. Okay, again, I'm using a different computer. And, okay, thank you. Thank you, appreciate that. Okay, so let me talk about a different subject first, which I rarely talk about, and that is censorship. Okay, that's got very little to do with what we talk about in this channel, but it turns out that they censored one of my videos that I recently put up there. Okay, and I broadcasted it live. Okay. And this is the one day I found this note from YouTube saying, your content was removed due to a violation of our community guidelines, okay? And threatened me with a strike, or really they were about to give me a strike, okay? And I was supposed to review the content. Then they sent me a second message, okay, right after that. And it said something like, warning, content deleted by the user, etc., etc. It says content removed. If this happens again, your channel will get a community guideline strike. Okay, and I won't be able to do certain things. Okay, so yeah, it was quite threatening. What was the issue about? Well, again, this computer runs slow, so I'm going to have to go a little slower here. It was about this video, okay? Funny thing happened on the way to Mars. And it had to do very little with Mars. It had to do more with the fact that on that video, I mentioned, two words really. The first word was autism, right? One of those. And the second word was that I was talking about homosexuals. And it's like if you say homosexual and you say autism, immediately the YouTube radar picks it up. And it's kind of dangerous because immediately you have operators from YouTube, going in there and trying to find out what you're talking about. And they use their own discretion, which is not always very good. And they send these messages out saying, hey, you violated the community guidelines. And so I challenged it. I said, there's something wrong here. I was just talking about it scientifically. A couple of people asked questions about it. I clarified my point of view, that I think that a lot of that has to do with the fact that we lost genetic diversity. And what happened was they approved my appeal. In other words, this is what they sent me after that. They said, hey, appeal approved. Am I supposed to celebrate? What am I supposed do? Cheer, drink champagne? First they threaten me, and then they say, okay, you did okay, we granted your appeal. There was no reason to censor me in the first place. Okay, and what was I talking about? Well, I was talking about stuff like this. This is one aspect of it. This is something that I see happening lately in the world. You have reptiles that are born with two heads. Okay, and you say, well, is this normal? Have we seen this in the past, 1,000 years back, or is this a new phenomenon that's happening? And here you see another version, and that's the mammals. Okay, you can see some of these mammals also have two faces, two heads. And the question is, why are some of these animals coming out like this? Why are they being born like this? And I'm saying it's got a little bit at least to do with the fact that they've lost their genetic diversity. Okay, so that was my whole argument. Okay, and so, I have no idea why, as soon as they hear words such as autism or homosexuality, they immediately, the radar picks it up and sends it to, to the people to the judges. I think it's, and especially when the judges approve it, that means they haven't even watched the video, because if they would have watched it, they said, oh, okay, he's just talking about something scientific. Instead of just, sending you the message and then saying, oh, call us back if you want to challenge it. Okay. Okay, and so what's the argument? I've touched upon that a couple times, one more time just in case, so other people know what I'm talking about. This is Calhoun's experiment, and his experiment consisted in putting in an enclosure four couples of mice, and he allowed them to multiply. The four original couples were normal. They had children. They had nesting material. They had all the food they wanted. And the only thing that was really missing, they also were protected from diseases and predators. The only thing that was missing is space. Okay, they didn't have space, subject we're going to touch upon today. We get to it if the system doesn't shut me down here. And, what was the outcome of this? Well, the outcome is here. You'll see the chart. Let me make that a little bigger. Okay, and this is what happened. The mice multiplied, and when they reached around 2,000, finally came down to the point where they became extinct. And Calhoun was saying that this might be a blueprint for what has happened to humanity. But the big point that I saw in his study, he was a psychologist, and he was studying, the effect of space on the mind. And so he was in a different field altogether. But what struck me about his experiments, he did about 30 of them, is that that the mice at the end, he did it also with rats, became autistic and homosexual. So you could say that he's one of the first person, maybe even the first person, to have created homosexuality in the lab. Okay, so I'm saying, they had no injections. People talk about injection. They had the same food. It's not like the food came from corporations that that feed them some chemicals. It was all normal. And so when people say, well, homosexuality and autism, they're the result of eating, or the foods we eat, or the pollution, or injections and things of that nature, this is what they got to answer. This fellow produced homosexuality and autism in the lab without any of those factors, without any of those being variables. Okay, so that's what anyone who wants to address the problem has to tackle. Okay, he who believes that it's a question of food or a question of injections or whatever, that's kind of like a political issue more than a really scientific issue. Man, there's no reasoning, not too much. There could be a small effect, but I think the big effect here is the fact that you have the enclosure. You also have the founder's effect, okay, because they all came from the same grandparents, and I think that was the bigger issue. That's the underlying issue, I think, or the main point, the main factor. And I also had another video. It wasn't censored, or I guess you could say it's censored. Not censored in the sense that I was given a warning or that they gave me a strike, but in the sense that they said, that video, we're not going to allow you to put it for ads. They're not going to promote it for ads. And it was this one here, okay? I made videos on the Neanderthal series, called it Against Admixture. I'm saying humans and Neanderthals never had sex, okay? Or maybe one guy out there might have, I doubt that even. But the point here was that I went through this whole series, and when I got to number 12, I talked about rape. And these people heard the word rape, and immediately they put it, it's not for ads. They censored it for ads, essentially. And just because you talk about the word rape, yeah, it is a four-letter word. I'll grant that. But the issue here is that, I was talking about the fact that Neanderthals could not have raped a human female, for example, a male Neanderthal with a human female, partly because of that video number 13, the one next to it, shouting distance. The clan stayed together, not venture far from the clan, because any animal could attack them and kill them. So I think that pretty much they had to be more or less within shouting distance or whistling distance. Any member of the clan, you could not just wander off. And so the chances of and I think that happened to all monkeys in those days. You just can't stray too far from the clan. And what that means is that the chances of something like rape happening, I think, were slim, next to none. And so this is one of the theories that is out there. That's why I wonder why they censored this one when we're talking about a theory. And this is one of the theories in the mainstream. Okay, they say that these Neanderthals maybe raped a woman. There was some what do you call it? Some things going on between and women. Male Neanderthals with human females, and maybe vice versa, human males with female Neanderthals. And I don't think that could have happened ever. And part of the reason is that we share no mitochondrial DNA with the Neanderthals. That means we had no humans ever had Neanderthal mothers, according to that study, and no male humans had any Y chromosomes, which comes from the males from the male line. Okay, and so that kind of shuts down any interaction with the Neanderthals at all. But since they had no theories for the extinction of the Neanderthals, they created this nonsense that we had sex with them, and that because they were a smaller population, they kind of fizzled out in our bigger population. And what we have today is a little bit of their Neanderthal genes, which just as well, or probably did, come from when we separated maybe 800 or so 100,000 years ago. Okay, so when we separated with them, maybe even before then, maybe with the Heidelbergs, maybe even before that. I always think that it's probably with Homo erectus that this happened, where Homo erectus already was in England 800,000 years ago, or some biped, which is probably them. Okay, and and yeah, if there were some kind of human in England 800,000 years ago, you're talking about maybe the level of Homo erectus antecessor Heidelberg at best. From the Neanderthals descended, of course, we're going to have some chromosomes and some, not chromosomes, but some genes in common. And so I think that's why we have some Neanderthal genes in us, only because of that. Other than that, we never mated after that. Two different species. Too much time passed, more than 500,000 years. And so we were very different, not only in appearance, which already would scare the daylights out of any human, and vice versa. But, the chances of mating with them were absolutely none. And if there was some hanky-panky going on between one couple out of all those in those days, I don't think it would have created, the amount of uh, genetic similarities that we have, like 2% that we share with a Neanderthal, 2 or 3%. Okay, let's move on to another subject. This one has to do with a subject I've been talking about lately, and it's not finished yet. It's the ether. Okay, what is the ether? And I'm not talking about the stuff you smell. Okay, I'm talking about this stuff that people think is responsible or underlies gravity, underlies electromagnetism, maybe even light, right? And one fellow says the following, and I like to define the ether as really an etherist. I like to define an ether as a person who doesn't have the slightest clue what the ether is. That's the best definition of an etherist. Because if he knew what the ether was, he wouldn't be proposing the theories that he proposes. And here we have our first etherist. He says, the black sky we see in the ether made by threads and ropes. The black sky is made, meaning space, it's made out of threads and ropes. I don't think so. Change the word matrix with ether. So they just say ether's everything. Okay, the matrix is everywhere. In other words, it's everything, right? It's like God. He's everywhere. He's everything and therefore nothing. It's all around us, even now in this very room. Okay, you can see it. Bartender, I would like to have whatever he had, you can see it when you look at your window or when you turn on your television. Okay, I don't know what he's seeing, but I don't see the ether. I see images of different kind. I can point to it at all times. Good. If you can point to it, draw it. Very simple. If you can point to it, draw it. That's how simple it is. And so these people don't do that, and that's where I have a little bit of problems with them. Okay, so here we have different versions that you will find if you put this in Google Images. You'll get something like this for the luminiferous ether, okay? And what do you see? Well, what you see is a bunch of lines, arrows, okay? And if you zoom in on that, okay, you get something like this. More or less, they all say the same thing. This is what they're all pointing to. If I can get it up here. It looks like that. That's your luminiferous ether. Okay, so if you ever wanted to know, that's what it looks like. And so what are you staring at? Well, you're staring at a bunch of points that form arrows, and they're all going one way. And that's part of the problem, right? The ether can only go one way. And so you got to do kind of miracles to use this to explain both gravity and electromagnetism. That's one of the issues. Okay, it only goes one way. Okay, so what are we staring at? What are those arrows? What are those points that make up the arrows? What is this? And that's part of the problem. And usually they're referring to vectors, magnitude and direction. That's what the arrows usually represent. And that means that they're going to be doing math. They're going to represent it mathematically and put these arrows ad hoc, like, here's my arrow. Okay, so are all the arrows the ether? Are all the points the ether? What's the ether? And they never defined it. They never really pinpointed what the ether is. In other words, they never drew it, because if it's a physical object, you just can't draw it. That's how simple it is. And so we have to start at the beginning. What is the ether? I've already explained this in the past. And here you have, you have the, let me get this right. Okay, there it is. You have Mr. Aristotle there on the lower left. And what do you think of the ether? Well, all of them thought of them as particles. These were, ether means air. It's the air of the gods. And they always thought of air as particles. And the only was, whether there was space between the particles and whether there is anything such as space, whether space exists, and whether there is movement, whether the particle had a place to move into. These were the issues they talked about. You have to remember that Democritus and even before him, Leucippus, they were, over 100 years, they came over 100 years before Aristotle. And so, they already discussed particles. They said that all there is atoms and empty space. Atoms meaning particles. This is how they viewed it. And so they did talk about particles in those days. And they thought of this as particles. There was a debate, but they all debated about particles and whether the particles had a place in which to move. So the ether was thought of as particles, but as particles that the gods breathe. That's more or less the notion. And certainly in the 19th century, when you have all these waves, electromagnetic waves, they were trying to figure out what light is. What was it? Well, it was the undulation of all those particles. Went up and down, all these waves, the standing wave of particles. That was more or less the notion they had. And that survived until today because you have the quantum version, okay? And this, I can't remember exactly where I got this from. I'm sorry about that. I usually put the reference. It's either Wikipedia or maybe even from one of the physicists out there, mathematical physicists. And what is he saying? They're saying modern science does not equate vacuum with nothing. This is going to be important for the next subject, which is the multiverse. Okay, so they're saying vacuum is not always nothing, or sometimes they do, sometimes they don't. And some people do equate the vacuum with nothing. They say that it's the ether. And some people make a separation and think of space as a container of ether. And so you have to be careful with which group you're talking to. You're talking about at least the ether, right? It says, indeed, the vacuum in quantum field theory is filled with what? Virtual particles. Okay, so it's filled. That means that they separate or they distinguish between the vacuum, in other words, space, nothingness, and what's in it, which are all these virtual particles. And I'm assuming if they're talking about particles, they're talking about some kind of corpuscle, and each one has to have shape. That means each one is separated from the next one by what? Well, hopefully by space, because they have to identify what separates one particle from another. And there you see it on the next slide. It says the quantum vacuum is often viewed as a modern version of what? An ether theory. So yeah, the quantum, they never abandoned the ether. The ether survives until today. They call it the space-time. Other people call it the false vacuum or the quantum vacuum. They're talking about the ether. They're talking about a space filled with particles. That's what ether has always been. And then you see there it says a space consists of selected mathematical objects that are treated as points. What are points? Particles. That's what they mean. But they use the word points because they're going to talk about it mathematically. And mathematically, what is a point? Well, it's a number, a value. That's what a point is. And they say the nature of the points can vary widely. For example, the points can be elements of a set. Again, what are they talking about? Numbers, functions on another space, or subspaces of another space. Now, they're talking about numbers. They're not talking about physics. Okay. It is the relationship that defines the nature of space. Okay, so you can see that quantum really treats, the vacuum as full of particles. And that's what the ether has always been. That's the notion of the ether theory. Okay. Here, just to rub it in, here we have a Nobel Prize. His name is Robert Laughlin. I've touched upon him a couple times. And he says the following: the modern concept of the vacuum of space, right? Vacuum of space. I thought vacuum and space were the same thing, but he says the vacuum of space, confirmed every day by experiment, is a relativistic ether. But we don't call it that because it is taboo. Yeah, you can't use the word ether, but they never abandoned ether. From the days of the Greeks all the way to today, ether, bunch of particles, it's always been the same thing. Some equate the particles, the ether with space. Others say, no, the space contains the particles. And others, like the other fellow the other day, he said, no, ether is neither. Ether is potential. Okay, so we don't know what the ether is. And again, I like to say that an etherist is a person, the best definition, right, is an etherist is a person who does not have the slightest clue what the ether is. And if he did know and he's going to treat it as an object, he's just got to draw it. He's just got to put it up there for us to see. Okay, and so here is the difference. For those of you who can't tell the difference, some people say that my threads, my ropes, they're the ether. I haven't discovered anything new. So here I put them side by side so you can distinguish. If you have eyes, you'll be able to tell the difference. Here it is. The ether is the guy on the left. And the rope model, which is a single thread in the entire universe that weaves all the matter and all the ropes that interconnects every single atom, that's the one on the right. Okay, so is the one on the left the same thing as the one on the right? Well, hopefully you say no. Otherwise, you need to see an ophthalmologist. Okay, you got a problem with your eyesight. Okay, so no, the ether is not the same thing as the rope model. We have no place for a bunch of particles. That's what the ether is. If you think the ether is something different, draw it. Don't tell me I'm wrong. Draw it. And that's exactly what this fellow said. A second fellow, he's been at this for over a month. He says the following is, why the freak? Who the freak cares about Greeks' thought on the ether, what the ether was? They never saw the ether. Yeah, they never saw it. They never claimed to see it. They didn't even know what air was. Yeah, they thought of air as particles. Okay, and that's quite clear. Okay, they didn't even know what air was. He says, you're just as stubborn, arrogant, as despicable, narcissistic as your twin brother Ken Wheeler. Please, come on. At least they got a little more hair than he does. So long, Bill. I'm subscribing. Well, sorry to see you go. Not because of the subscription, but because you are abandoning with your tail between your legs. I thought you were going to take this to the end. I thought we were going to really have a discussion here. After all, I'm putting your theory here, on the line, and I'm discussing it. It's not like I'm avoiding I'm showcasing your theory. And so, for him to abandon and leave and run away with his tail between his legs, it's because he cannot answer the questions. Okay. And I've been, torquing the screw more and more, trying to get an answer from him. And one of the questions that I asked him is, what does the ether look like? I think it's a valid question. I'm asking, if you're going to treat ether as a physical object, you say it's a thing. Okay, draw it. Illustrate it so that we know what you're talking about, what's going through your head. I'm saying it's a bunch of particles. You say it ain't. Don't raise straw men. Okay, we conceded. You want to call the ether whatever you call the ether, no problem. Make a picture of it. Show us what you're talking about. Well, after 1 month, he did come through and he came with his ether blob. See if I can put this up here for you. This is the notion of the ether, okay? And he says, that's the ether. Here, I'm drawing ether for you. Okay, so here's the red ether blob. That's what he refers to as the ether. Okay, then he explains, he said the ether goes in the South Pole, it comes out the West Pole or the East Pole, I don't know, one pole, and where's surrounding ether, it bends back towards the South Pole again, Taurus. Okay, in the case of a magnet, it's obviously a loop. In the case of gravity, ether goes into an atom and exits and enters the next atom, and so on. Okay, that's how he visualizes this thing. This is what determines the flow of ether. He's talking about the flow of flow, or what I call the flow flu, or the flu flow. It's a fluid flow, or the flow or the fluid. The flu flu, woodchuck, wood, seashells by the seashore. Okay, I'm back here. Okay, this is what determines the flow of ether. Great. And whatever medium that pleases you. No, it's not a pleasing me. You got to tell the story. You're giving the presentation. Okay, and of course, how masses appear to attract each other. I've been working on this for many years. Okay, so what's the problem? What he's showing there? Well, he's showing 3 things at least, if not 4. Let me point them out to you. There's a blue stuff, and he's saying that the ether is space as well. So there is no contrast between space and ether because he's saying that space and ether are the same thing. So I need to know what the blue stuff is if the red ether is both ether and space. What is the blue stuff then? That serves as contrast. And of course, they never get to that point because they say, "Oh, Bill, you're just doing word salad, semantics." Now you got to tell me what the blue stuff is because you're giving your blob contrast. That's the first one. The second one is that you see those hexagons that build the whole shebang, which is the whole blob. If the whole blob is the ether, you got to tell me what each one of the hexagons is, not to mention each one's the lines that comprises the hexagon. You got to identify each one of those things. You can't just say, there it is. You know, you got too many things in that picture. You got to identify each one. Okay? And he doesn't do that. And so he says they're all one. The blue stuff, the red stuff, the hexagons, the lines that comprises the hexagons, all of it is the ether. And yeah, when you cover all the bases, you know, so that nobody can challenge your object, the thing that you're presenting, your hypothesis, which are the objects that you must present, and your definitions, if they're all the same, but yeah, it's like God is everything. And yeah, you can do many things, many magic tricks if God is everything, if your blob is everything. And so, yeah, and this is his blob in motion. Okay, this is how he presented it. Okay, you can see how it's moving. Okay. And so he's saying, yeah, this is the ether in motion. And again, we need to identify what the blue stuff is. We need to identify what the hexagons are, why one hexagon is separated from another, what the lines are. You can identify each one, explain each one, or draw each one separately. You know, draw a line and tell me what each line is. Draw a hexagon and tell me what a hexagon is. And then draw the blob and the blue stuff. Identify those as well. And he doesn't do that. Of course, he says, there's your blob. You want a drawing? There it is. Okay, so we know what it looks like, more or less what he has in the back of his mind. Okay, so what is the trick? With this, he's got to explain what we asked him to explain, and that is this. Here we have, okay, a spoon, and I'm going to let go of it, and it falls downwards. We call that effect, that phenomenon, we call it gravity. Okay, no biggie. I think we're all familiar with it. Here's an illustration of that. You see the spoon falling downwards. What does he have to explain? Well, he's got to explain why is the spoon coming down in the case of gravity. This is gravity, right? And so you would think that there's either push from above or pull from below. Something is in contact with a spoon that we can't see or touch. He's got to make that thing visible for us because something is in contact with a spoon. Otherwise, we're introducing black magic and saying it's done by remote control. God does it. Angels do it. Spirits do it. Okay, you can't do that. Not in physics. The way it works in physics, you gotta make visible the invisible, intangible objects that is pulling or pushing on the spoon. And as far as I'm concerned, there's only push or pull. Okay, but this fellow, he invented a new form, or he thinks he invented a new form of contact, of physical contact. He calls it entrainment. What in the world is entrainment? Well, entrainment means push. You're carried with the flow of you're in a river and a river carries you because it's pushing on you. So he calls that push, which he equates with the Venturi effect, where you have this constriction in one place and that forces you to go faster in a given region. Okay, and he calls that entrainment. Fine, but entrainment is push. That's all it is. All you've done is push. So you're not pulling, you're pushing. You're just being carried by the river. And he never understood that in his many years of studying the ether. Okay, so he says, no, it's neither push nor pull. It's entrainment. Okay, we call it push in science. Okay, and there it is. He says the spoon is being pulled downwards, I guess, or pushed from above. Here I'm illustrating pull because he says that the ether is between atoms. So here supposedly we have the atoms of the earth on the bottom and a spoon on the top. The ether is between them, and somehow this entrainment, this river, is pulling the spoon downwards. That's the best I can explain it from his point of view. If he doesn't agree with it, well, he can come back and clarify for us what I'm interpreting wrong. Okay? So I can't tell you what is going through his mind. All I can tell you is that this is what he's describing. And again, it's a description. And I'll tell you why. Give me a second here. This computer works a little slower. Okay? And here, let me show you why. Because this is the equation of the Venturi effect. The Venturi effect has this equation: pressure at a position 1, pressure at position 2, density of the fluid, right? And velocity of the fluids. That's what the equation is for the Venturi effect. What is all that? That's just an equation. What's an equation? A description. Venturi effect is not an explanation. He doesn't understand the difference between an explanation and a description. And of course, he's going to say, well, you're just doing semantics. You're just doing word salad. What you have is a description. We have no explanation of what causes, what the mechanism is. All you're saying, if I press here, it flows faster. There's more density over here and it flows faster. That's all he's saying. He's not explaining why it flows faster. He's just saying it does. And that's the Venturi effect. It's just a description, mathematical description. He never understood that. Much like the flat earthers, they talk about, gravity being density related. Okay, density is not an explanation. Density is a description. There's more over here than over there. Why does it go from more density to less density or vice versa, whichever one you like? You got to explain that. You got to explain the flow of matter. And hopefully the matter doesn't just flow because it likes to flow. It flows because something is pushing on it or pulling on it. If you don't put push or pull, if you don't have physical contact, you're doing black magic. It's just as simple as that. Okay, so what did I ask this fellow to do? And he hasn't done that. So again, I got to do it for him because he says the blob, this ether thing, is between two atoms. Okay, so I put two atoms in there and I said, okay, show me what's in between the atoms. Okay, so he's going to put his ether blob. Okay, here it is. That's what he put in there. Okay, he's put his blob. Okay, and so I said, okay, let's see. Same with this. He's going to produce pull, I guess, because one atom goes towards the other. I would think that's pull. I'm not sure how you can turn this into push. Okay, here's another version of this. Give me a second here. Okay, maybe it's like that, sideways. Okay, I don't know how he's going to put his blob. It's up to him to tell me how he wants his blob put in there. Just in case, I did push as well. Okay, here's push. Okay, the blobs are on the outside pushing each particle inwards. I don't know if this is the one that he's referring to. Probably not. Okay, just in case, I have another version of that one as well. Here it is. Okay, hold it. Here it is. Give me a second. Like that. Okay. So you have all these versions of push and pull. Just in case, I put another version. Here it is, where the two particles are within the blob. Okay. So maybe it's something like this. And again, all I can do is look at the possibilities based on what he explained. And he says, so far all we have is description. We have no idea why one particle is pulled towards the other. He says, I put the blob in there. It's self-evident. Do you understand? No, we don't. Okay, we don't understand because you haven't produced it. You haven't shown me why one particle is going towards another, especially in a straight line rather than going around. That's one issue. Here's another version of this one just in case. So, I try to cover all the bases. Give me a second here. Okay, that's another version of it. I don't know which one he wants. It's up to him. I don't know if he's got a version that I have not put here. Here's a third version of this, okay, like that maybe. I don't know what else to do. I'm putting it in every way that I can imagine that he's going to produce pull or push. I don't know. I guess he's doing pull of some kind, or maybe they're pushing from the outside. I don't know. He's got to tell me which of these scenarios is the one that he proposes. And I want to clarify one more time, the black stuff that you see in the background, he says that's ether too. It's a static ether while the other ether moves. It's like we have a shearing effect where you have the black, which is standing still, and the other ones that move. He has to justify that. He says it's all the same stuff, which clearly it ain't. Again, you see the hexagons, you see the lines making up the hexagons. All that's got to be clarified, what he means by each one of those things, because these are all different things. And so he's got like 4 different things there aside from the atoms. He says the atoms are also made of the stuff. So there is no difference between the ether and the particles also, even though he's got a shearing effect between the black stuff and the stuff that's moving, the red and blue stuff there. So I don't know. It's up to him. He's the guy who's got to tell us what his mechanism, his proposed mechanism is. I cannot put words in his mouth. He's got to put words, into the screen so that we can see his mechanism. Okay, and all I can do is illustrate what he's talked about, and that's all I can do. Okay, so here we go back to his original, and there it's not in motion, but this is the blob. This is what he presented. I took a snapshot of it as opposed to it running, because we need to first identify the object. We can always put it in motion later on, and you can see that what he's got to identify. He's got to identify the blue stuff, the blob, the whole shebang of the red stuff. He's got to identify the hexagons that form, the many hexagons that form the blob, and also the 6 sticks that form each one of the hexagons. But at least the hexagon's got to be justified. That at least. If he doesn't want to justify the sticks, we can let him off the hook. But he's got to justify the hexagons and the blue stuff. Okay, and so the ball is in his court. And I think it'll be forever in his court, because he put his tail between his legs and started running. Okay, let's get into the subject matter of today, which is the rope model of the multiverse. And before I can get to that, I gotta again compare and contrast the official version of the multiverse against the one from the rope model, because they're different, and I want you to see that difference, because that's essentially the main point of the lecture today. So I start with this fellow, and his name is Larry Kraut. I think that's his name. What does Larry say? Well, he says a universe from nothing. What is he referring to? Well, he says he can build matter, something, from nothing. And he's got the process, he's got the mechanism, he's got the causes. And boy, am I interested in this subject. If you can produce something from nothing, especially without God, but I'll even concede God. I'll put God in there. No problem. I'll let you have God. I want God to go to his garage, to his workshop, right? And show me how he builds something from nothing in one frame. Single frame, from one frame to the next. Here we have nothing. And in the next frame, suddenly we have something. I want to know the mechanism. And there's no frame in between, because we went from nothing to something, and I want to see what the mechanism is. And I'm not sure you can produce a mechanism without a frame in between. So I have a problem with suddenly something popping out of nothing. But that's what his book is about. You see, how is he going to explain this? I mean, obviously he's trying to sell a book. Okay, that's his main point. But how do you do this? This is quite a miracle. And so I was interested in finding out, because let me tell you what the issue is. The issue is that we're going to have a multiverse. What separates one universe from another? And you can't say space, because space, as far as I'm concerned, doesn't have a fence where space stops and something else continues, as far as I know. I mean, but he who proposes that has to illustrate the fence. Okay, so you got to put a fence there at the end of space, and then tell me what continues. What continues? Another space. There's a fence dividing one space from another. So how can you talk about a universe when, as far as I'm concerned, universe is space and matter? That's the universe. Otherwise, you got to define the word universe before you talk about multiverses, multi-universe, multiple universes. Okay, so that's the train of thought here. Okay. And so he said something from nothing. He's going to create a universe from nothing, meaning he's going to create matter and space from nothing. I thought space was nothing, but apparently good old Larry has a different view. And so we have to look at this word nothing. What is nothing? Especially if we're going to be separating one universe from another with this nothingness. What is this nothingness? Okay, and how is it different from space, which I thought was nothing? So yeah, we got to get to the bottom of this word nothing. And so we look it up, and it's what we see. It says nothing, no thing, or no thing. Okay, they have different ways of saying, okay, great, is the complete absence of anything, the opposite of everything, or its complement. Well, all that they did, and this is out of the Wikipedia, is put an antonym. They say nothing is the opposite of something, and something or anything is the opposite of nothing. And so we have no definition of either one, or we have our antonyms, okay, and antonyms like synonyms, they're circular definitions. In other words, no definition at all. We have no definition of the word nothing. Early Greek philosophers argued that it was impossible for nothing to exist. Well, there I have to be on their side. Yeah, nothing cannot exist because only objects can be said to exist. You cannot say that space exists, or that nothing exists, or that vacuum exists, because what do you mean by exist then? And yeah, the atomists, by the way, Democritus and Leucippus, right? The atomists allowed nothing but only in the spaces between the invisibly small atoms. For them, all space was filled with atoms. And again, you're talking about space being filled. And again, this is where the notion of space as a container arises. They treat space as, oh, we're filling space, like you fill an ocean with fish, and they're displacing this container or this medium called space. No such monster. You don't fill space. You do not displace space. Space has no surface, so it's not like you're pushing space all the way to the edge of space where another medium continues. So yeah, this notion of filling space, that's what's irrational. You got to define space before you can say that, and space is nothing, and nothing, what is nothing? Well, obviously if they say it's the opposite of something or anything or a thing, well, then we got a problem, okay? Because then nothing is the opposite of something, and what is something? Well, it's no nothing. That's what something is, no nothing. We have just negatives. Okay, Aristotle took the view that there exists matter and there exists space. Again, there exists space. No, space cannot be said to exist. A receptacle, in other words, what? A container of some kind, into which matter objects can be, or material objects can be placed. Okay? Yeah, again, space is not a container and space exists. Are you kidding me? And that's because they didn't define these words. That's the issue. It is word salad what they're doing, not what I'm doing. I'm trying to define these terms so we can talk rationally. They never defined it. They're doing word salad, or failing to do so, meaning they're failing to define words. And here you have, this became the paradigm for classical scientists when, in the days of Newton, from then on, scientific revolution of the 17th century, Descartes argued against the existence of empty space until the scientific discovery of a what? A physical vacuum. Talk about an oxymoron. All they said, a physical something, vacuum, nothing. So we have a something, nothing. That's what a physical vacuum is. So yeah, these people just put words in there, what we call word salad, okay? That is a play of words. And why? Because they never defined any of them. That's why they can get away with this nonsense. Okay, and what is space? I mean, that was nothing, and space is not nothing, so what is space if it's not nothing? Well, let's find out. Space, in which three values, coordinates, are required to determine the position of a point. That's a space. What's that got to do with physics? All they're saying is, look, we have three, what? Not coordinates, called number lines. They have all these three number lines, and they determine a point, which is what? A position, or a point, which is a number. That's what they're talking about. They're saying, look, it's a pair, ordered pair, or an ordered triplet, or a quadruplet, or whatever. And what they're talking about is how to locate something. with coordinates, really meaning by number lines. And more commonly, it is defined as three-dimensional Euclidean space, n space, etc. Dimension n equals 3 that models physical space. Again, the something nothing. A space is a set. Set? What is a set? Sometimes called a universe. So now they have a universe. Okay, we have the set, the space, the universe. They put it all, bunch it all together with some added structure. What structure? There's no structure in math. Well, modern mathematics uses many types of spaces, such as Euclidean spaces, linear spaces, topological spaces, Hilbert spaces, probability spaces. They have all these spaces. It does not define the notion of space itself. So they have no definition of the word space, but they use the word space. They say, oh yeah, we locate points within space with 3 number lines. And what do you mean by space? Oh, we don't know. We just locate points in space. That's what we say. So they treat it as a container, as a physical object, and they're only talking about math, how to locate a point using number lines, 3 number lines in this case. Sometimes they use 2 number lines for the typical Cartesian coordinates. Okay, a space consists of selected what? Mathematical objects. What the hell is a mathematical object? What is it, number 5? Is that a mathematical object? An equation, is that a mathematical object? That are treated as points. Yeah, numbers, that's what they're talking about. And selected relationships between these points, these numbers, that's what they're talking about. The nature of the points can vary widely. For example, what are they? The points can be elements of a set, meaning numbers, functions of another space, meaning an equation, of space or subspaces of another space, meaning numbers of numbers, subsets of numbers. It is the relationship that defines the nature of space. Yeah, and so we have a problem here because these people don't define their terms. They use the word liberally. They use words of ordinary speech. They say, well, you know what I mean. I'm talking about space. Oh, yeah, okay, I know what you mean. And what they're talking about is 2 coordinates, meaning 2 number lines or 3 number lines or 4 number lines necessary to locate a point where within space, which is a container, which they can't define, which they don't know what it is. They never defined it, but they said, we're going to use the word because we like the word. And somehow that crosses the boundary into physics, and now they're talking, they started with math, they end up talking about physics, say, oh, we can tell you what the universe is like because the physical world is represented in the language of math. That's the whole story. That closes the circle. Okay, so what's the problem with Larry? Well, here, let some other people talk for me. Okay, here's one fellow, and his name is David Albert. He's a physicist, mathematical physicist who went into philosophy, really. And he says the following. He criticizes what Krauss says about nothing. He says, the main theme of the book is the claim that we have discovered that all signs suggest a universe that could and plausibly did arise from a deeper nothing, involving the absence of space itself. Okay, so space is not nothing. Space is different. So space came into being from nothing. Okay, yeah. I understand everything. And which may one day return to nothing. We go from space to nothing, okay, via processes that may not only be comprehensible, but also processes that do not require any external control or direction. Physicist David Albert said the book failed to live up to its title. Universe from nothing. Larry's misuse of the term nothing. Absolutely. If matter comes from relativistic quantum fields, the question becomes, where did those fields come from, which Krauss does not discuss. If you look at his book, okay, at least from the analysis that I've seen, I haven't read the book, I don't care to read it, because obviously it's nonsense, it's poppycock. He's going to equate fields with nothing and say there were fields out there. And from the fields we have space. What is space? A bunch of particles that are made of fields, vibrating fields. What are fields? Nothing. That's more or less his train of thought. And so you say, hold it, what are these fields? Where did they come from? That's nothing. So I don't have to justify it. That is the nothing. That's more or less his argument. And here the New York Times also did an analysis, and it puts it clearly where I just mentioned. Certain arrangements of the fields, for instance, correspond to there being 14 particles in the universe. This is out of his book, Larry Krauss' book. and certain other arrangements corresponding to there being 276 particles, and certain other arrangements correspond to there being an infinite number of particles. Okay, so we have countless particles, great. And certain other arrangements correspond to there being no particles at all. Okay, no particles at all. Okay, so what do we have if we have no particles? And those last arrangements, the one no particles at all, are referred to in the jargon of quantum field theories. So he's saying, look, there are no particles. What you have is fields. Okay, what are these fields? For obvious reason, as vacuum states. So he's saying a vacuum state consists of fields. Fields are not particles, even though you have Sean Carroll saying that particles are the vibration of fields, local vibration of fields, right? Because he's trying to explain how space-time is related to quantum, right? And so here we continue. It says, Krauss seems to be thinking that these vacuum states must amount to the relativistic quantum field theoretical version of there not being any physical stuff at all. So he's saying these fields are nothing. So he doesn't have to justify it because he's reached the end of the line. He says, I'm there already. I've proven that space and matter came out of nothing. What is nothing? A bunch of fields. What are fields? Nothing. And that's why I don't have to justify it. I already proved my point. You missed it. And he has an argument, or thinks he does, that the laws of relativistic quantum field theories entail that vacuum states are unstable. Okay, so who cares? And that, in a nutshell, is the account he proposes for why there should be something rather than nothing. So he doesn't start from nothing. He starts from fields and equates those fields with nothing. And he says these vacuum states are unstable, meaning they're already in motion because they're unstable. And so what is it that is in motion? And he says it's nothing because fields are nothing. Even though you have Sean Carroll saying, well, fields are something, the vibrations of fields are what particles are, which is what fills space, and we call them virtual particles because they can come in anytime they want at the request of a mathematician, ad hoc, just pull it in whenever you need it, briefly so that you can't measure it or detect it, and then it goes back to being space again. And so what are these fields? Well, fields are space. So are they something or nothing? Do they have shape or not? Or what are we talking about? Are they just vectors? Well, what are we talking about? And so, yeah, they never illustrate their theories because they can't. That's the issue. Just like the etherists, they can't illustrate their theory. Because as soon as they illustrate it, you pin them against the chords and start pounding them. Okay, so here's another fellow. His name is Neil Tyson, and he does most of the same thing. He proposes the same thing as well as Max Tegmark and some of these other fellows, Brian Greene and so on. Our minds cannot fathom the idea of a multiverse. Yeah, you cannot because you have no way of separating one clump of matter, as I call it, from another if they all share the same space. And what is universe? Space and matter. And so unless you can put a fence between one universe and another, you cannot talk about multiverse, many universes. Quantum fluctuations would be responsible for another universe having slightly different laws of physics than ours. Yeah, great. You got to separate and not tell me about laws. You got to tell me physically what separates one universe from another, not tell me that they have different laws of physics. Okay, you haven't justified that. You're just talking out of your ears, nose holes. New universes are created, forming an endless number of worlds. Yeah, that's a great statement. You got to tell us what separates from one universe from another. And we have to distinguish a little bit here between the multiverse to some degree and the many worlds version of quantum mechanics, which is for every step you take, you branch off into a different universe. And that's only a way of eluding the question. People say, well, why did this happen? And they say, well, in this universe. But in another universe, something else happened. Here you won the lottery. Over there, you lost the lottery. So they don't have to explain anything. They just have to say you just branch out in different universes. Why? Because they're talking about statistics. They're saying statistically all these things could have happened. And they all did happen because quantum allows for all of them to happen. And if they all did happen, they can't happen in the same universe. They have to happen in separate universes. And that's a little different than saying physically there are all these clumps of matter. We'll call this one universe 1, this one universe 2, this one universe 3, and we have the multiverse. which means that you have to tell me what separates one universe from another. Where's the fence? What is the fence? Tell me what separates one universe from another. And if we all share the same space, it's just one universe, because universe is matter and space. Okay, and that's where you got to begin, definitions. And again, here we have this fellow, Robert Laughlin, again, just for you, reminding you again that they talk about the ether. So what is space? Space is ether, bunch of particles. That's what it's always been. Nothing's ever changed. So if space is a bunch of particles, which is what he's saying there, or space contains countless particles, it's all filled with space, with particles, and these particles, the virtual ones at least, can pop into the real world, whatever that means, from the non-real world, and for a brief period of time, so that they affect something that you can't measure and then go back. Well, that's great. It's something you can't prove, you can't measure, and they just say it is so because we have no other way of explaining our equations. Okay, I see how it is. You just do ad hoc things. You put them in by hand. Okay, great. Okay, so that's what space is. It's full of particles, okay? So I don't care if it's full of particles. You got to tell me what separates one universe from another if you're going to talk about the multiverse, okay? And so once again, I show you the difference between the ether world of quantum mechanics, which is the same one they've always had, bunch of particles and a single thread, because I'm going to contrast my multiverse from theirs. And I'm going to say that a single thread comprises all the matter in one universe. Why is it one universe? It's one universe because all the matter made by that thread, weaved by that thread, every atom and every rope that connects every atom is made of a single thread. And it's a closed loop thread. So anything that is not attached to it comprises, you can say, a different universe. The problem here is that you have to separate one universe from another, and you can't, because you got to put a fence around space. Then you can separate one universe from another. And so what you have to do is put either the fence or say there's only one universe. So what is that single thread? Well, it forms a clump of matter. That's the best word I can come up with. You can call them an island, whatever you want to call it. You can call it island or clump. And we have one thread that makes up all the matter in our universe, but it's not connected. None of those atoms are connected to the atoms of another universe. That's the idea, okay? So what we have is something that, but we've got to begin with a definition. So let's begin there first so that we have it in the right context, okay? This is the definition of something, that which has shape. What is an object, thing, entity, substance? Those are synonyms of the word something. What is nothing? That which doesn't have shape. Synonyms, there you have them: space, vacuum, void, nothingness. What is universe? Something and nothing. So it includes the nothing. Universe includes space. Universe includes nothing, includes vacuum. You can't get away from that, because otherwise you either have matter or you have nothing. You have space. If you want to talk about universe, you got to put them both together. That's what the word universe means. Okay, we got the definitions. Okay, you got some other definitions, no problem. You got to defend them. You got to bring them up, say this is what universe is, this is what nothing is, this is what something is, no problem. You got to put them out there and defend them against attack. And I have no problem attacking you. Believe me, I love it. Just like I attack the ethers, the flat earthers, electric universers, and the mainstream, I'll attack you too. Okay? If you don't follow those definitions, I need to know why. You need to defend those definitions. You can't say, well, it is so because I like it, and my brother likes it as well. Just the fact that your brother voted for your definition doesn't make it so. You got to defend it. Okay, so here's our version of the multiverse. Okay, we have all these threads, and of course, each one of those forms all the matter comprised by one of those threads. Okay, so each one is separated from the others. That's the only thing I want to show here. Okay, so you have each one of these threads. They have, in our universe, you can say the one on the upper left there, That's our universe, and it's a certain size, I guess you could say. It has so certain amount of thread. Maybe the laws of physics, as they say, are different. In other words, maybe the speed of light is different from the other universes. Maybe the atoms are different sizes, different masses, etc. That could be if we're made of different amounts of thread. But this would be the notion of the multi-universe in the rope version. But what we're talking about is not multi-universe. You're talking about a single universe. What you're talking, because they all share the same space, because you can't put a fence around space. The thread there that you see is not a fence. I'm just putting it there so that you can see this. And here, let me show you. You would have all these clumps of matter, and again, you got to forget about the thread. Okay, the only reason I put the thread is you can see it better. But what you're saying is, look, all these atoms in one universe are all connected to each other, and they're all made of a single closed loop thread, which is not connected to any of the others. The universe is one. The clumps of matter, island, whatever you want to call those are, you could say, multi-universe, multi-clumps, multi-islands. And within there, within each one, you have galaxies. Within each one, you have stars and so on. That's the notion that we have for the rope version, rope model of the multiverse. Okay. And so this takes us to our conclusions. First, let me show you what the conclusions are for the establishment. They never define the word universe. That's a big problem. They never define the word space or matter for that matter. They have no idea what any of these words mean. They just use them. Ordinary speech, they say, you want to know what they are? Look in the dictionary or go ask, what is a philosopher, physics, or a English major, librarian, any of those. They treat the universe as a thing. They treat space as a thing. They treat them as both as a nothing and as a thing. They treat it as both something and nothing. And that's why they get away with murder. Okay. Universe out of nothing, according to Larry. Yeah, we got a problem there because he says it comes out of fields, not of nothing. And of course, he's going to elude the word field. And that destroys his entire book, which is out there only to make money. That's it, because of his name. Because he's more or less a celebrity in the world of mathematical physics. Physics being too big for him. Expanding universe, what is that? What is expanding? It's space. It's this dark energy that's blowing everything apart. What is that dark energy? What is that space? Well, it's something. What's it pushing against? It's an unscientific question because we don't know, where the universe ends. It's like asking what's north of the North Pole. What are you talking about here? You're talking about what's outside of space, and why is it an irrational question according to them? It's because we have no way of proving it. So it's not really so much of an irrational question. It's an unscientific question, a philosophical question, because we have no way of verifying what's outside of space. No, it's very simple. Draw space, and we'll know what's outside when you identify it in your picture. Then we'll know what's outside of space. You have to tell the crowd, not say, hey, guess what's outside of space? And yeah, we can't prove it because we can't go outside of space. Not even God can step outside of space because he's got no boundary to cross. So to say outside of space is irrational because space is that which has no shape. It has no boundary for even God to cross. Poor fellow's looking for the end of space. He's still trapped in here with all of us. So what does multi-universe mean? Well, it really means, under the rope model, right? It means islands, clumps of matter, but we all share the same space. But under the mainstream version, until they define space, until they define the word universe, we'll never have a clue what they're talking about when they say multiverse. They talk about the different laws of physics. They don't talk about physical separation, which is what we need if we're going to talk about multi-universes. And how does it relate to the fourth dimension? Only God knows. Okay, and God's in the fifth dimension. Okay, and so here's the conclusion for the counterpart, the rope model. Okay, here you have it. We have the single thread model of the universe. That's the whole universe as far as we're concerned. But there's nothing wrong, nothing preventing us from having multi-threads. Okay, each one of those comprises an island. a clump of matter. Okay. The thread is an object, so we're talking about something physical. Now we're not talking about mathematical concepts such as field and energy and any of that. Um, uh, we could have many single threads out there. Uh, they're unconnected. That's why remember, they're closed loop threads. They're unconnected to each other. So none of those atoms from that universe are connected to any of the atoms in our universe. So we have each one is made of its own single thread. Okay, and they could have different speeds of light, different masses for the atoms, all that kind of stuff. What does exist? Well, it's object plus location. So we have an object. It's called a single thread. Does it have location? Well, the only way it can have location if there are other clumps or single threads out there. Okay. And yeah, we can say that, we can speculate and say, yeah, if there are other clumps of matter out there, our universe can be said to exist, following the definition, right, strictly, because, one universe has location with respect to another universe, and these universes all are disconnected from each other, okay, so no problem there. And so we can use the word exist in that context. Otherwise, it's irrelevant. We're talking about existence of matter within our universe. And for that, all you have to have one object, any atom, or anything made out of atoms, having location with respect to another group of atoms. That's it. We won't figure it out, through any test or experiment. This is just, an entertaining issue to ponder, a philosophical issue. Could there be other universes out there? Well, it's something to kick around at the water cooler. Nothing more than that. We'll never figure it out. This is just speculation, and it's nice to talk about it. No more than that. It's not like we said, "Oh, I'm going to prove to you that there are other universes." No such monster. And in that sense, it doesn't mean it's unscientific. It just means it's nice to talk about it. Nothing more than that. Okay, let me get to some of the questions and comments that people made since last time. Okay, here's one fellow. I know this one. This one is someone put the to the chat GPT. They put something about light and the thread, whether the ropes, the threads, whether light could be a thread or vibration of a thread or something along those lines. Here it is. He says down at the bottom, how does light work? What could transmit a signal going from both directions between all atoms at a constant speed of roughly 300,000 kilometers per hour? The formula for speed is the wavelength of the object multiplied by its frequency. It's a wave equation. So what did ChatGPT or smart computers or robots there reply? Well, here it is. Says it took all the conditions that this all put into consideration, and there you have it at the bottom. He says, let's imagine a vast interconnected web of ultra-thin, almost invisible threads that stretch between all atoms. These threads vibrate at different speeds and lengths, and the vibrations travel along the threads at a constant speed. When an atom plucks a thread, the vibration travels along it, interacting with other atoms it's connected to. The speed of the vibration is determined by how tight or loose the thread is, which corresponds to its wavelength and frequency. So it did not explain. It just what the ChatGPT did was give us a description of what would happen if we simulate light with a thread. That is more, the way I guess ChatGPT understood it is if the thread has a standing wave of sorts. So they said you have this thread, you wave it up and down, you have the oscillations, it travels at a certain speed. But see, they were able to use that to come to the equation, the wave equation of little c, velocity of light, 300,000 kilometers per second, equals the frequency times wavelength, when each one is opposite the other. When one rises, the other one, they're inversely proportional. When one goes up, the other one goes down. And so ChatGPT answered the question, at least from a descriptive point of view, without any problem. So it means the model works. Okay. Now, whether you believe in it or not, that's a separate issue. But ChatGPT already is on record saying the rope model works. Okay, and it didn't do the rope, it did the thread, but it should be a rope, really. But no problem, it got close enough. The guy asked the question through threads. Okay, here we have a first question or a comment. First it says, your step number one is hypothesis. Yes, in a scientific method, right? Why do you purposely avoid observation? Using one of your human senses. Yeah, observation, eyes, you see, right? Um, as a logical first step, you're actually anyone's method, right? Missing this simple obvious might put your entire work under suspicion. Well, we're not here for belief. Okay, so it's not a question of suspicion. The question is, do you understand? Okay, and it's a pity. Well, what's the problem with this fellow? He uses the word observation. He talks about observe. He says, don't you have to observe something before you can start science or physics? The answer is no. Okay, guy comes to the blind, deaf, quadriplegic. Well, not deaf. Let's make him here, but we'll kind of say that he's blind and he's quadriplegic. He never touched. He never saw. Okay, so we have no observation, no touching, no tangibility. And a guy comes to the sage, this blind quadriplegic sage, and says, look, let's imagine a situation in the land of the Klingons, and we have let go a spoon, and it always falls to the ground. What could be causing that? And the guy explains it. He said, the sage, he says, look, maybe all atoms in the spoon are connected to every atom in the Klingons' planet that make up this Klingons' planet. And maybe as they fall, these extensions, they fan out. And as it falls faster and faster and faster. There's an acceleration of gravity. He explained something he never saw, something he never touched. We do not need observation. In fact, the way we do it in science, and please learn it well, we do it the mafia way, the gangster way. We kill the witness. We do not observe anything. We do not witness anything. We do not testify to anything. The first thing we do is kill the observer. So no, it's the other way around. Observer is the first thing we eliminate from science, from physics. Because every time everybody introduces the observer, meaning, what did you measure? Well, this is what I measured. I don't give a hoot what you measured. Explain the mechanism. That's what we want. And we don't have to be seeing or touching anything. The guy can just say, let me tell you what I imagined. I imagined a cow falling from the sky, falling on the earth. What could be causing that? And I give you a cause. I give you a mechanism for that phenomenon you just described. We're done. You don't have to observe anything at all. Okay, so no, observation is not part of the scientific method. The mathematicians put it in there. Why? Because without observation, meaning measurement, they cannot introduce experiments. What is the purpose of experiments? To convince people, to persuade them. It's to introduce it as evidence. You do an experiment, now what are you going to do with that? You're going to introduce it as evidence to convince the jury. So the only purpose of experiment observation is to persuade, not to explain. That's why it's not part of a scientific method. Okay, here we have another fellow, and he says the following. If ropes deform, how can they be one piece? To deform, different parts of an object move independently from another. Okay, if there are parts, those parts need to be held together. Ropes aren't tangible to themselves, but they seem to be tangible to atoms. So why aren't atoms tangled in the ropes? I would like to know the mechanism that makes something intangible tangible. Well, this fellow is talking about religion. We're not talking about science. What's the issue here? The issue is the thread is made of a single piece, and we postulate, we hypothesize. That's what it's called. We make the assumption. Let's repeat those words because he doesn't understand what I just said. We're going to make an assumption, a supposition. We're going to hypothesize. What other synonyms are there? We're going to make believe, okay, that the thread is made of a single piece and it has the property of being flexible. Why? Because those are the properties we see in our world today. In the world today, we have a single thread, and this thread makes up every atom and the ropes that interconnect them, and all these atoms are able to wiggle with respect to one another. And the only thing different between a solid and liquid and gas is the fact that the amount of movement they have, the amount of flexibility. But the thread has all those properties. That's why it's not an unreasonable assumption to say that the thread is flexible, okay, and can become rigid between two atoms in the form of a rope. Why? Because if you lower the frequency, meaning you got something very, very cold, the colder it is, the less frequency there is, and the less it moves. Okay? So, yeah, the thread is flexible and can turn into something rigid. Okay? And there is no process, there is no mechanism. That's why it's religion, what he's talking about. He's trying to come up with a why God made it that way. That's what he's trying to talk about. That's what he's saying essentially. Why did God make the thread flexible and made of a single piece? Yeah, it's not made of parts. It's not made of atoms. It's not made of little points or particles or segments or whatever you want to call them. It's made of a single piece, but it is flexible. That's an assumption. That's what it's called. Okay? And there's no why to an assumption. It just is. Okay? Why is it is? Because it's an assumption. You say, I'm going to give it these properties, and from that, we're going to build our theory. Now, if you don't like the assumptions, then you have to question the assumptions, and no problem, you can question the assumption, but I'm not sure how far you're going to get, because we're saying, let us assume. And you say, well, I don't want your assumption. Well, you don't want my assumption. I'm sorry. Then you won't understand the theory that's founded upon that assumption. That's the way it works in science. So there is no why to it, because why, you're just asking, why did God make it flexible and made of a single piece? It just is. There's a beginning to a theory, and it starts with hypothesis. That's how it works. And you have to have the definitions, you have to have the properties of the thread, and we've got all of those, so I'm not sure what his problem is. He's just thinking in terms of three-dimensional world where we have today that water is flexible and ice is not. And you say, okay, why? Because they're all made of particles, and why is this one flexible? Why is that one not flexible? And the issue is the following. He doesn't understand that there's something between them, because there's this wave, and they're saying that when the wave has high frequency, then it's flexible. When it has very low frequency, meaning long wavelength, then it's rigid. And he doesn't understand that. That's the first thing he's got to go and research before asking the question. He's never done that. He doesn't understand that there is something between two atoms, except that the mathematicians, the people of quantum, they say it's a wave, it's a field. And he's okay with that. He said, okay, it's a field. Now I understand. Now you haven't understood anything, because as we just discussed, no one understands what a field is. Field is a bunch of numbers. That's what a field is. You can't say the numbers are rigid or more flexible. So you can't use the word field or energy to explain that. You got to put a physical object and say this one's rigid and this one's loose. That's the way it works. And we put a rope in there and say, look, if the frequency is low, it's cold, it's rigid. Frequency is high, heat, it's flexible. Okay, and last one here, fellow talks about the shadow, saying he's got shape. He says, of course I meant that the part of the shadow on the surface, in other words, the shape of the cross-sectional projection of the ball outline, not the shadow in the middle of 3D space. The ball indeed has shape. Great. Ball is 3D, it has shape. Yeah, hopefully. But he's saying that the shape is the circle. Like from your vantage point of view, you just see a circle. Okay? That isn't the same thing as the shape to which I refer. Okay, what are you referring to? Much as a globe is not the same as a flat map projection. All he's saying, again, in different words, run around and saying the same thing. He's saying, look, shape refers to 2D, form refers to 3D. And I've already explained. Let's go through them again. English is probably the only language on the planet where there's a difference between the word shape and the word form. Everybody just uses the word form in other languages, at least most of the ones I know about. That's one issue. They only have the word form. Then I showed the other day that the word shape is a perfect definition, a perfect synonym of the word form, and vice versa. Form means shape, shape means form. There is no difference between them, especially in physics. So to say, well, a circle has shape and a sphere has form is nonsense. That's his notion of it. That's not what the books say, that's not what the dictionaries say, and that's certainly not what physics says. And one of the reasons physics doesn't say that is that if you're going to make a presentation, and I'm going to show you, I don't know, for example, a wave. Now we're talking about mathematical physics. And I show you a wave. And a wave is obviously 3D, because you have the magnetic field perpendicular to the electric field. So obviously you have 3D there alone. And they always put it in 2D because, I can put that in a 2D platform. What are you going to say? Oh, no, I'm not going to allow you to do that because you're talking about 2D and there's no such thing as a 2D in physics. No, the guy is making a 2D representation of a 3D object, like if you put a cube there and you say, look, this is a cube, and you put the projection. Now, what's coming from the screen is 2D. It's just a flat square or rectangle of some kind. But you say, look, that's a cube, and we give it projection with the mind. What's coming out of the screen is 2D, but what's in your mind is 3D. You say, okay, I see what the guy's trying to say. And the same thing goes for the wave. The wave is 3D, but you put a 2D wave because you're explaining something. Are you not going to allow the person to talk and say, oh, because that has shape, but it doesn't have form, so now I'm not going to let you give the presentation? See, by using the word shape, if anything, it covers both form and shape, assuming you were right and shape only referred to 2D, because 2D is part of the 3D. And by saying shape or 2D, you're covering all the shapes, all the objects in the universe. By distinguishing them, well, you have to justify why you're distinguishing them. And you're saying, well, we only use 3D shapes in physics. Do we? Do we use cubes, perfect ideal cubes? Is that part of the real world? Or is that an imaginary thing? Cones, ideal cones of, solids, of Euclidean solids. Are those real things? Perfect cones, smooth, not made out of atoms? Are those part of the real world? So no, you cannot use, you have to justify why you're going to use form instead of shape, and not the other way around. I don't have to justify it. With that, I'll see you next week if I get here back in time. Otherwise, I'm going to have to postpone the next class until I get back to Frankfurt. We'll see you then. Bye-bye.